Systems of equations. We're going to talk about the elimination method now. So remember, systems of equations is looking for the one point where the two lines cross. That's it, just the one point where the two lines cross. Now, we could always graph, but in actuality, we only ever want to use the graphing method when the instructions say we have to, because it's really a very inefficient method, especially if we aren't very exact and careful, if we've got a really odd point where they cross that's not right on the lines, all kinds of things. So graphing is not the method we want to use. For the most part, the method we want to use is the elimination method, also known to some people as the addition method. I like calling it the elimination method because it reminds me I'm eliminating something. But we're doing it by adding, so that's why it's called the addition method. So once again, let's say we have our problem. We're going to label our point or our equations, equation number 1 and equation number 2. So that's equation number 1, and 3x minus 7y equals -6. First of all, make sure you wrote it correctly. Okay, so here's how the elimination method works. I look at my x's and my y's and I decide which do I want to get rid of, x or y. Here's the things I look at. First, I look at where are my signs opposite, because in order to get rid of these, the coefficients in front of the x or the y, whichever one we're going to get rid of, has to be exactly the same. And my signs have to be opposite. So I'm going to have to do some manipulation of equations here. So first I'm going to see where signs are opposite. Well, I've got a positive 3y and a negative 7y. So that's a possibility of getting rid of the y. However, the next thing that I look at that is even more important, I think, is I look at the coefficients in front of each of the variables and figure out what would be the number that I would have to get these to both be so they're the same. So in other words, it's like a lowest common denominator. So if I look at 2 and 3, the quote-unquote lowest common denominator between those would be 6. So I would have to get both the 2x and the 3x to be 6x. If I did it with the y, I would have to get them to both be 21. And again, as you well know, I like to keep my numbers small. So even though I'm going to have to manipulate with a negative on the x, one of them at least, I will go with the x's because the number is way smaller than the y's. So what I have to do now, I'm going to start with equation 1. What do I need to do to get the 2x to be 6x? Well, I need to multiply by 3. So I put a little 3 next to so now I know that I'm going to have to multiply every term in the first equation by 3. So 2 times 3 is 6x, and 3 times 3 is 9y, and let's see, 19 times 3, that's 27, so 67, okay? And then, now I need to remember that I'm going to have to make this second one negative. I could have made the first one negative, doesn't matter either way, but I'm going to have to make the second one negative because they have to be the same numbers but opposite signs. Otherwise, I can't get rid of them when I add them up. So what do I need to multiply with the 3 to get 6? Well, 2, but I'm multiplying -2. So -2 times 3x is -6x. -2 times -7 is positive 14y, and -2 times -6 is positive, and that's 12. Now, always put a line under this, guys, and we're going to add these up now. But when we do, if you notice, 6x minus 6x is gone. It's been eliminated. And we have 23y equals 79. Oh, and hang on just a second. I just realized that I messed up over here. 19 times 3 is 57 because 3 times 1 is 3 plus 2 is 5. So 57. And that makes this 69. And now I just need to divide both sides by 23, and I get y equals, well, 23, 24, 60. Let's try 3 and see what happens. 3 times 3 is 9, and 2 times 3 is 6. So 23 goes into 69 3 times. Now I have my y coordinate, but I don't have my x coordinate yet. So now I'm going to take this y and put it back into either equation number 1 or equation number 2. Doesn't matter. As long as I label it, I'm going to try equation number 1. And we're going to go 2x plus 3 times 3, because y is 3, equals 19. And now this time I'm going to solve for x. So I get plus 9 equals 19. And then I'm going to subtract the 9 from both sides, divide both sides by 2, and I get x equals 5. So my one point where these two lines cross is 5, 3. Let me check to see that these are correct. So first equation, 2x plus 3y equals 19. So 2 times 5 plus 3 times 3 equals 19. Always put it into the original equation. So we get 10 plus 9 equals 19. 10 plus 9 is 19, and that 19 equals 19. But I have to do it in every single equation. So 3x minus 7y equals 6. Oh, geez, all these things will not stop coming up. I apologize. I thought I got rid of it, but I didn't. Okay, so 3 times 5 plus, minus 7 times 3 equals negative 6. Well, 3 times 5 is 15, and negative 7 times 3 is negative 21, and 15 minus 21 is negative 6 equals negative 6. And there we've got it. So I can, my final answer, the one point where these two lines cross, is 5, 3. Okay? Now I'm going to do this exact same one again. And we're going to get rid of y this time instead. Just so you can see, it doesn't matter what you decide to get rid of, as long as you're careful with how you manipulate this stuff. Again, always easier to do smaller numbers, but doesn't mean you have to. So we're going to get rid of y this time. That means both of these have to be 21, but I already have opposite signs, so I don't need to worry about that. So what do I need to multiply with 3 to get 21? Well, I need to multiply 7. So 7 times 2 is 14x, and 7 times 3 is 21y equals, again, 19. Let's hope I multiply correctly this time. That's 60. Well, actually, it was the adding, wasn't it? And that's 13. So 133. Somebody check me and make sure I did that right. And we'll find out really quickly. What do I need to multiply with a 7 to get 21? Well, that's 3. And again, I don't have to worry about signs because they're already opposite. So 3 times 3 is 9. And 3 times 7 is 21. And 3 times 6 is 18. Put a line, and now we're going to add these up. And again, when you notice, we've got positive 21 and negative 21. They now, when I add them up, are gone. We eliminated them by adding them. And so here we get 23x equals, well, let's see, 13, that's 5, 2 minus 1, 1. And let's see, 20, 40, 60, 80, 1. Let's try 23 times 5. That's 15, 10. Oh, look at that. So when I divide each side by 23, I get x equals 5. 23 goes into 115 5 times. Well, now I'm going to take that x and put it back into either equation number 1 or equation number 2. Well, we did 1 last time, so I'll do 2 this time, so you can see it doesn't matter. Okay, so 3 times 5 minus 7y equals negative 6. Okay, so this is 15 minus 7y equals negative 6. That's going to be negative 7y equals 6 and 15. It's negative 21. Divide both sides by negative 7, and we get y equals 3. And so our answer is 5, 3. Well, it better be the same as last time. Where'd it go? 5, 3. Now, I'm not going to check this one because we already did that. Okay? Excuse me. And the next example that I have is quite extensive. So I'm going to do a second video for that. And then maybe I can get the special things in that one as well. So, next video, please.